Hi, I'm Patrick Reagan. Welcome to the Wired Networking Part 2 Physical Media and Connectors, Fiber Cabling and Transceivers. The video covers fiber optics cables and its connectors. It also covers transceivers that are used in networking. Fiber optics cables consist of one or more optic fibers that are used to transmit data. Fiber optic cables transmit data as pulses of light that go through tiny tubes of glass or plastic. Infrared technology is fundamentally used in fiber optics as the light transmitted through optics fibers is primarily in the infrared spectrum, allowing for efficient, long-distance data transmissions with minimum signal loss. This is because infrared light experiences lower attenuation within the fiber compared to visible light. The transmission capacity of optical fiber cable is 26,000 times higher than that of twisted pair cable. The fiber tubes are very thin and can break and crack relatively easy. The bend radius of fiber optics cable is a crucial parameter that specifies the minimum radius one can bend the cable without causing damage or significant performance loss. The cable should not have any bend radius smaller than 10 times the cable diameter. The core is the central part of the fiber where light travels. Claddings surround the core and has a slightly lower refractive index, causing light to be reflected back into the core through total internal reflection. Core and cladding size are measured in microns or micrometers. Common sizes include common core and cladding sizes for multimode fiber is 50/125 microns or 62.5/125 microns. Common core and cladding sizes for single mode fiber is between 8/125 and 10/125 microns. The first number represents the core diameter and the second the cladding diameter. Fiber optics cables can be divided into single mode fiber and multi-mode fiber. Single mode optical fiber has a small core and only allows one mode of light to propagate at a time through a single direct light path. It supports long-range communications up to 100 kilometers without processing and supports speeds up to 100 gigabits per second. It uses expensive light sources such as laser. Common core and cladding sizes are between 8/125 and 10/125 microns. Yellow cables are usually SMF. Multi-mode fiber cables come with a larger core and is designed to carry multiple light rays or modes at the same time. It uses multiple paths of light, often bouncing off the cladding. It provides short-range communications up to 2 kilometers, and it uses relatively inexpensive light sources such as an LED. Common core and cladding sizes are 50/125 microns or 62.5/125 microns. It supports speeds up to 10 gigabits per second. Orange and aqua cables are usually MMF. Fiber cabling uses several connectors. Straight tip, or ST, is one of the first standard fiber optics connectors, which uses a spring-loaded, half-turn bayonet-style lock that makes it quick and easy to attach and detach. Subscriber connector, or SC, sometimes referred to as a standard connector, has a push-pull mechanism to latch them in place. Lucent connector, or LC, is a small form factor, half the size of an SC or ST connector, which is ideal for heavily populated patch panels and cabinets. It is also known as local connector or little connector. It's more difficult to remove after connected. LC connector extraction tool is available to help a little. MT-RJ is common in-home installations which only works with multi-mode optical fiber. Today, LC is the most common connector found. There are connections which have dual or duplex connections, and others with single or simplex connections. When choosing cable types, you have to select connector type, simplex versus duplex, and if it's single mode or multi-mode. Two common fiber connectors used in high-density data center applications to connect numerous fibers with a single plug-in action are multi-fiber push-on, or MPO connector, is a type of fiber optics connector that allows multiple fibers to be connected through a single connector. And multi-fiber termination push-on, or MTP, is a specific, higher performance version of the MPO connector, essentially a registered trademark by US Conic, which offers improved mechanical and optical characteristics compared to standard MPO connectors. A network transceiver, also known as a media converter or network interface controller, is a device that both transmits and receives digital signals over a network. Transceiver is a combination of a transmitter and receiver in a single package. It is a critical component in network communications, allowing for the conversion and connection between different types of media or interfaces. The functions of the transceivers include: transceivers send and receive data over a network, converting electrical signals to optical signals and vice versa, allowing for communication between devices using different physical media. Transceivers ensure compatibility between different networking standards and interfaces, enabling seamless communications across diverse network environments. Some transceivers can detect and correct errors in data transmission, improving the reliability of network communications. Transceivers allow switches and routers to connect to various types of network media. Whether it's a copper cable using RJ45 connectors or different type of fiber optics, single mode or multi-mode, transceivers can be swapped to match the specific type of cabling in use. Using transceivers make network devices more modular. Instead of having a fixed number of ports for each type of media, switches and routers can be equipped with empty slots where the appropriate transceivers can be inserted. This modularity allows for easy upgrades and changes to the network without needing to replace the entire switch or router. It should be noted that transceivers will come with a rubber cap that is used to keep dirt and debris out of the transceiver when not in use. By using transceivers, organizations can buy switches and routers with the base number of ports and add more ports or change the type of ports as needed. This can be more cost-effective than purchasing new devices every time the network needs change. You add the transceiver that matches your network. Transceivers allow for future-proofing network investments. As new transceiver technology and standards emerge, they can often be used in existing equipment. This protects the investment in switches and routers by extending their useful life. As you can see from the bottom picture, transceiver modules are easy to install. You slide the transceiver module into the transceiver port. You then remove the rubber cap and plug in the fiber connector. A transceiver protocol is a set of rules for how a transceiver sends and receives data. Transceivers are electronic devices that combine a transmitter and receiver to send and receive radio waves or electrical signals. Some of the common transceiver protocols include the following. Ethernet, or IEEE 802.3, is widely used for local area networks or LANs, utilizing electrical signals over copper cables or optical signals through fiber optics cables. Fiber channel is primarily used in storage area networks or SANs for high-speed data transfers with its own dedicated protocols, not following the standard OSI model. The most common form factors for transceivers include the following. Small form factor pluggable, or SFP, supports speeds up to 1 gigabits per second and supports both copper RJ45 and fiber, single mode and multi-mode. It is used for gigabit Ethernet connections, flexible and hot swappable. Enhanced small form factor pluggable, or SFP+, is exactly the same size as SFPs, but it supports up to 10 gigabits per second. It's primarily used for fiber optics, but also supports copper. It is commonly used for 10 gigabit Ethernet connections. Quad Small Form Factor Pluggable, or QSFP, combines 4 SFPs into a single transceiver with speeds up to 1 gigabits per second, which totals 4 gigabits per second. It can aggregate 4 data streams into a single link or similar combinations depending on the variant. It supports both fiber and copper. It's used for high-speed data transfers, particularly in data centers. Enhanced Quad Small Form Factor Pluggable, or QSFP+, with speeds up to 10 gigabits per second, which totals 40 gigabits per second. It supports both fiber and copper. It's used for higher speed connections, often used in aggregation and core network layers. SFP transceivers are right-handed. From their perspective, they transmit on the right and receive on the left. It is their right, your left when you're looking at it. They're usually small arrow symbols or TX or RX symbols at top of the transceiver to show direction. Bi-directional or bi-di transceivers are designed to allow data transmission in both directions, different wavelengths using a single fiber optics cable, which helps reduce the amount of fiber required and simplifies the network infrastructure. Bi-directional transceivers come in SFP, SFP+, QSFP+, QSFP28, XFP, and SFP28. Sometimes your ISP or provider will give you a fiber connection and you will need to connect to an RJ45 Ethernet switch. If this happens, you can replace the switch with a switch that has a fiber connection or transceiver port that will accommodate fiber ports. You can also use a media converter, which almost always requires power. Question: which of the following cable types would most likely be used to provide high-speed network connectivity between nearby buildings? Answer: fiber. Question: you're replacing a damaged fiber optics cable that goes directly to an SFP transceiver on a network switch. Which of the following cable connectors should be used? Answer: LC. Question: which of the following fiber connector types is the most likely to be used on a network interface card? Answer: LC. Question: which of the following connector types would have the most flexibility? Answer: SFP. Question: which type of transceiver can support up to 40 gigabits per second? Answer: QSFP+. Question: you have an incoming fiber line that you need to change into an RJ45 copper connection that will connect to an internal switch. What would you recommend? Answer: media converter. Which of the following network cables involves bouncing light off a protective cladding? Answer: multimode. Question: a network technician has terminated cable to a fiber patch panel in the MDF. Which of the following connector types is most likely in use? Answer, SC. Question: which of the following cable types provides the highest possible transmission speed? Answer, fiber optics. For more information, visit these sites. In summary, fiber optic cables consist of one or more optic fibers that are used to transmit data. Fiber optic cable transmits data as pulses of light that go through tiny tubes of glass or plastic. The core is the central part of the fiber where light travels. The cladding surrounds the core and has a slightly lower refractive index, causing light to be reflected back into the core through total internal reflection. Single-mode optical fiber has a small core and only allows one mode of light to propagate at a time. Multimode fiber cable comes with a larger core and designed to carry multiple light rays or modes at the same time. The Scriber connector, or SC, is sometimes referred to as a standard connector, as a push-pull mechanism to latch them in place. Lucent connector, or LC, is a small form factor, half the size of an SC or ST connector, which is ideal for heavily populated patch panels and cabinets. Today, LC is the most common fiber connector found. When choosing cable types, you have to select connector type, simplex versus duplex, and if it is single mode or multi-mode. Two common fiber connectors used in high-density data center applications to connect numerous fibers with a single plug-in action are multi-fiber push-on, or MPO connector, and multi-fiber termination push-on, or MTP. A network transceiver, also known as media converter or network interface controller, is a device that both transmits and receives digital signals over a network. Sometimes your ISP or provider will give you a fiber connection if you need to connect to an RJ45 Ethernet switch. Thank you for watching this video. The next video will be Wired Networking Part 3, Wiring Basics. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.